Okay, assignment 6, office hours. These are the answers. You should have checked them already, but here they are again real quick. Pause the video if you need to. So first ones, now you need work on these even odd ones. Tables, preferably. So here's the next ones, find inverse functions. A little bit of inverse trig in there. Why not, with the theme of inverse functions. On the back, got a bunch of graphs. So let's work. And some absolute value graphs. All right, so let's try these out. See what the work should look like to get full credit. So these ones are doing little tables to find symmetry. So plug an x in, getting a y out, plug a, negative a. So pretty much all these are like this. So plug a and you get 6a, plug negative a and you get negative a in there, which is negative 6a, and then you're going to compare these. The fact that they're the opposite of each other means that it's odd symmetry by the origin. So that's the kind of work I'm looking for on these and on your next test. Plug a in, 5a squared plus 3. So usually you plug a and it's just, but you plug negative a in. I kind of want to see this just to see you simplify it. So that's going to be positive 5a squared plus 3. These are equal to each other. They're the same, which means that's an even function because the left side is the same as the right side. So here, a negative a cubed plus 6a, negative a to the third plus 6 times negative a gives you negative a cubed minus 6a. Now what you might do, say, well, let's factor negative out, and you get a cubed plus 6a, and so now it's very clear that these are the opposite of each other, and so that's odd symmetry. xy, a negative a cubed plus a squared, negative a to the third plus negative a to the second gives you negative a cubed plus a squared. Now some of you guys might think, oh yeah, these are the opposite. Look, positive and negative. No, because if you were to take negative out of everything, it wouldn't be the same. So this messes it up right there. So this is actually neither. They're not the same. They're not opposite. So it's not going to be odd or even symmetry. So that's the work I'm looking for, though, to convince me. Otherwise, you could kind of guess on your tests, but I'm not going to give you any credit unless I see supporting work and the right kind of supporting work. So you plug a in, get a to the fourth plus a squared over 2a, negative a to the fourth plus negative a squared over 2 times negative a. Now this is going to be positive a to the fourth plus a squared over negative 2a, which is the opposite. Another way to write that would be negative parentheses a to the fourth plus a squared over 2a, and then that makes it very clear that this is the opposite of that. So since it's the opposite, it's odd symmetry. Okay. xy, a negative a, sine a over a, sine negative a over negative a. Now we are going to use some trig identities here. Sine of negative a is negative sine a because it's an odd function. And then you have a negative down here, and so it ends up becoming positive sine a over a, which means that these are equal. They're the same. And so it's an even function, even symmetry. All right, xy, a negative a squared plus cosine a over a, negative a, parentheses squared plus cosine negative a over negative a. So that's going to be positive a squared. Now cosine negative a is the same as cosine of positive a. That's the identity for cosine. over negative a. So these are the opposite. I mean, you could take it one step further and take the negative out, put it out in front of parentheses of the whole thing, and it's very clearly the opposite. And so then we get odd symmetry. So this is the kind of work we're looking for here. Table, xy, a negative a, 3a over a squared minus 9, 3 parentheses negative a over negative a squared minus 9 gives you negative 3a over positive a squared minus 9. These are the opposite. So it is odd symmetry. Okay. Got a few more. A negative a, 8 over 4 minus a, 8 over 4 minus negative a, which gives you 8 over 4 plus a. That is not the opposite. It's not the same. It is neither. Okay. xy, a negative a. Now you have to leave these absolute values. You have to. If you get rid of them, you're missing an important idea. That should be positive. So it's going to be absolute value a plus a squared over sine a. All right, I guess I could have just wrote that to begin with. Now, when we do negative absolute value, we put negative a in, put negative a in, put negative a in. So this is going to be the absolute value of a plus a squared over negative sine a. That's a trig identity. So these are actually the opposite of each other. Because you got a negative here, so that's going to be odd. Okay. xy, a negative a, 10 to the a, 10 to the negative a, which is 1 over 10 to the a, neither. Now, you guys could probably imagine what this graph looks like anyways, right? It looks like that. It doesn't have any kind of symmetry at all. A negative a cubed plus a to the fifth over 6a sine a, negative a to the third plus negative a to the fifth over 6 times negative a sine a negative a gives you negative a cubed minus a to the fifth. Now, this is going to be negative sine a, right? And there's another negative, so it's going to be positive 6a sine a. And these are actually the opposite because you could take a negative out of everything on the top. And you have a cubed plus a to the fifth over 6a sine a. And these are the opposite. So that is an odd symmetry, odd function. Okay? All right. That's the kind of work I'm looking for, though, on those. Okay, inverse functions. This is algebra skill. Swap the x and y's, solve for the new y. So the first step is to swap the x and the y, and then solve for the new y. So we're going to subtract x. 2y equals 4 minus x. We're going to divide by 2. Y equals 2 minus 1 half x, or y equals negative 1 half x plus 2. And that is your inverse function. Okay. Swap the x and the y. Solve for the y. Got to get rid of the square root by squaring both sides. Add 3. Add 3. So the inverse function is y equals x squared plus 3. So you're going to have a problem like this in your next test. Hopefully it's pretty straightforward. It's a skill that you should have learned before. Swap the x and the y. Now, how do we get that y out of that exponent? We take log of both sides, or natural log, or any kind of log base, but log base 10 is actually pretty convenient because they actually totally cancel each other out. And you get log x equals y minus 2 plus 2 plus 2 So the inverse function is y equals log x plus 2. There you go. Next one, swap the x and the y. I would cross multiply. X plus xy equals y. Get your y's on the same side. X equals, factor the y out because you can't combine the terms because the coefficients aren't like each other. Divide both sides by 1 over x. So the inverse function is y equals x over 1 minus x. There you go. Okay, swap the x and the y. Cross multiply. Xy minus 2x equals 4y. You get the y's together on the same side. Either side, really. It's up to you. You want to factor the y out and divide by 4 minus x. So the inverse function is y equals negative 2x over 4 minus x. Now, one other version of this that you might have got if you solved a little differently would be positive 2x over x minus 4. You could divide negative out of the top and bottom. Same thing. Okay, next one. Swap the x and the y. Solve for the new y. Cross multiply. Xy minus x equals y plus 3. We could get the y's together on the same side. Get rid of the other non-y terms to the other side. Factor the y out. X minus 1. X plus 3. Divide by x minus 1. Y the inverse function is y equals x plus 3 over x minus 1. Getting the hang of it? You guys remember doing this back in maybe even algebra 1? Swap the x and the y. Wherever you see an x, it's a y now. Wherever you see y, it's an x now. We can factor the y out. So we can solve for the y. Divide both sides by x minus 1. So the inverse function is y equals 1 over x minus 1. So find the inverse function. All right, we got a little inverse trig in here. So this is asking you sine of theta equals 1/2, and you're trying to find theta essentially, right? You take inverse sine of both sides. So you're saying, well, when does sine equal 1/2? You say, well, reference angle is 30 degrees or pi over 6. Definitely going towards radians. What quadrants is it positive? Well, quadrant 1 and quadrant 4, but this is principal values. So it's always, principal values always include quadrant 1, no matter what, for sine, cosine, tangent. And then another quadrant that's touching quadrant 1, either quadrant 4 touches quadrant 1, but quadrant 1 beats it. So principal values will make sure you only get one answer. So we don't need to do the K stuff. It's just quadrant 1 for sure. That's it. Done. One answer. So the negative value would be quadrant 2 or 3. Principal values are never quadrant 3. Okay. They're always quadrant 1, and there's always another quadrant touching quadrant 1 that represents the other sign. So the answer is 30 degrees, pi over 6. Let's do degrees and radians. Okay, when does cosine equal 1/2? 60 degrees, pi over 3. What quadrants is it negative? 2 and 3. Principal values will always be a quadrant touching quadrant 1, so that's got to be quadrant 2. It's never quadrant 3. So that's it. That's our answer. This equals quadrant 2 be 180 minus alpha, so 120 degrees, or pi minus pi over 3, which would be 2 pi over 3. You guys should be able to do those, from memorization. Okay. So when does sine equal root 2 over 2? 45 degrees. Pi over 4. What quadrants is it positive? 1 and 2. It's always going to be quadrant 1. If quadrant 1 is one of them, it's quadrant 1. So the answer is 45 degrees pi over 4. Okay. Okay, next one. We got to work from the inside out, order of operation. So this is saying, when does cosine equal root 3 over 2? Well, that's 30 degrees pi over 6 alpha. What quadrants is it negative in? Quadrant 2 and quadrant 3. Well, it's got to be quadrant 2. So that's going to be sine of quadrant 2 would be 180 minus alpha, so 150 degrees, or 5 pi over 6. Same thing. So then you say, okay, well, what's alpha? Well, we could have just used what we just said. It's 30 degrees pi over 6, and it's in. That's it. That was. It's in quadrant 2. So sine of 30 degrees, sine of pi over 6 is 1/2, and quadrant 2 is positive. That's it. There you go, little inverse trig. Got some graphs to sketch, kind of like on the warm-up. Anything important, vertex, asymptotes, intercepts should be labeled with dots or lines, and equations of lines, and coordinates, and so forth. So this is a parabola that's been shifted up 3. I mean, you could start with parent function, and then you shift it up 3. Right? And this is the vertex, and it is at 0, 3. All right. This is now x to the 2/3. We could start with that graph. That's 0, 0. Cube root of 1 is 1. Squared is 1. Negative cube root of negative 1 is negative 1. Squared is positive 1. So this is a Siegel function. 2, 3, 4, 5, 6. Anyways, it's kind of like this. All right. And then the minus 2 shifts it to the right 2. Okay. And then the plus 1 moves it up 1. You do get a left half on it, because you can take odd roots of negative. So this is sort of like a cusp right here, and it is at 2, 1. Okay, this is x squared minus 9, so we could start with the parabola, which looks like that. The minus 9 moves it down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 1 over 1, up over 2, up 1, 2, 3, 4, over 2, up 1, 2, 3, 4, over 3, up 9. Anyways, so that's your parabola. It's been moved down 9. Now the absolute value, the positive part stays the way it is. Absolute values of positives are still positive. But then it flips the negative part up. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And absolute values outside functions usually cause these really sharp corners. This is like a vertex here, I guess. 0, 9. Okay. This is an exponential, and the parent function is y equals 0. It goes through 0, 1. That's the point I want you to keep track of on these exponentials. The minus 2 moves it over 2 units to the right, so we're keeping track of that point. So now it's at 2, 1. Right? And then the plus 3 moves it up 3 units. 1, 2, 3, up to 4. And it moves the asymptote, horizontal asymptote up 3 units, label it. And so, final answer. Label that point, 2, 4. All right. A couple more. Got a log graph. Now, log graphs, what I like to do, because unless you'll probably get really good at them at some point, but if it's been a month, you'll forget. So I graph y equals 4 to the x. So it's exponential. Y equals 0, 0, 1. Okay, and then we're going to flip it across y equals x to get the inverse function, which is log. So we're going to get 1, 0. Vertical asymptote, x equals 0. So that's what we get. The negative flips it upside down for your final answer. Arrows on the ends. Okay. Sine curve pi, or 2 pi, 360 degrees is the period. Negative 2 pi, negative 360 degrees. XY axes, cut them in half, cut the halves in half again, cut it in half, cut the halves in half. Amplitude's 1. So the parent function is a sine curve 0, 1, 0, negative 1, 0. Over here is going to be negative 1, 0, positive 1, 0. Should look like a nice wave. Okay, now minus pi on the inside shifts it to the right, pi units. So that's right here. So this is going to be here. This is going to be here. This is going to be here. And it's going to kind of look, it's going to have the same look as if it got flipped upside down, which is a little weird. But it's just right. So now it looks like an upside down sine curve. And then the 2 is going to multiply the values by 2. So draw the points. Connect it. Nice solid line. Okay, period labeled. That's important. Max min's labeled. That's important. I guess intercepts would be 0, 0, pi 0, 2 pi 0, negative pi 0, negative 2 pi 0. All right. This is a parabola, parent function. That's been shifted down 9. Sounds familiar. 1, 2, 3, 4, 5, 6, 7, 8, 9. I think this is exactly the problem right above it. So, whatever. We can do it again real quick. So, one, 2, 3, 4. 1, 2, 4. So then the absolute value, negative parts stay. Or sorry, positive parts stay where they're at. Negative part gets flipped. 1, 2, 3, 4, 5, 6, 7, 8, 9. Sharp corners there. Okay, next one. We start with the line. -2, slope of 1. I mean, it's kind of up to you. This is going to be a V graph. Right? I mean, you don't have to, you could, so we shift it to the right 2, or I guess the original line is -2, up 1, over 1, up 1, over 1. And so it kind of looks like that. This is kind of an interesting take on how to graph absolute value, linear absolute value, which you maybe memorize as the V graph. This will show you why it's a V graph. The absolute value flips the negative part up. And so now the graph looks like that. And the negative flips it upside down. So now it's the upside down V graph. The 3 moves it up 3. So down 1 over 1, down 1 over 1, down 1 over 1. This point right here, 2, 3 is kind of important, right? That corner. All right, there you go. Got a sine graph with the absolute value inside of it, which we talked about in the lesson. So the sine curve, 2 pi 360, -2 pi, -360. Cut in half, cut the halves in half, get quadrants. Amplitude's 1, -1. Parent function 0, 1, 0, 1. Okay, and then so what does the absolute value on the inside of a function do? Well, any negative plug in behaves the same as the positive, so you get a mirror image. So you get a mirror image across the y-axis. So you definitely get like an even symmetry. So the right half gets flipped onto the left half, and the original left half disappears. Okay? All right. Okay, next one is 1, 2, 3, 4, -4. Up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. So that's the graph. The absolute value flips the negative part up. So up 2 over 1, up 2 over 1. So this is now what we get. And then that's with the absolute value. The plus 3 moves everything up 3. 1, 2, 3. Up 2 over 1, up 2 over 1, 2 over 1. Arrows on the ends. That's kind of an important point. 2, 4. That doesn't make sense. It should be 2, 3. My graph seems a little off, but you get the idea. All right. This one, if you plug in 0, you get 0. If you plug in 1, you get 1. -1, you get +1 because the cube root of -1 is -1 squared is +1. The next nice value would be 8, 2, 3. Because in cube root of 8 is 2, squared is 4. 1, 2, 3, 4. So that's the parent function, Siegel function, right? The minus flips it upside down. So dead Siegel function. All right, move it up one. Arrows on the ends. Label your axis. Okay. All right. Next one's a log graph with absolute values around it. So log graph, which is base 10, common log is the same. It's the inverse of y equals 10 to the x. So I'm going to start with that because I'm really good at graphing those. Y equals 0, x, y goes through 0, 1, right? And then the log graph is going to be a reflection across y equals x, where you swap all the x's and y's. So you can get 1, 0, get a vertical asymptote of x equals 0, and it looks like that. Now the absolute value flips this part up, right? When the negative flips everything upside down. So you get this, and you get this. You get this really sharp corner right there at 1, 0. So, okay. Now for these problems, we're going to use this graph. So I find it helpful to maybe go ahead and kind of just sketch that graph out real quick. Okay. The negative flips everything upside down, right? So that's going to be like that. That's going to be like that. That's going to be like that. And that's going to be like that. Okay. Next one, we could just sketch it out real quick. Like the parent functions we usually do. Now the absolute values on the outside are going to flip the negative parts up to make them positive. The positive parts stay where they're at because they're already positive. So everything's going to be positive. There you go. That's that one. Okay, next one. I'm just sketch it real quick. I find it helpful to have it. All right. Absolute value on the inside reflects the right onto the left, replaces the left. It doesn't force anything to become positive in the y direction, but you definitely get this very mirror image graph when there's absolute value inside of it. Okay, last one, absolute value inside and outside. Okay, I'm going to do a quick sketch. Now, I think we got to go order of operations, so we got to work on the inside first. So the inside, the absolute value on the inside replaces the left with the right mirror image. Then the absolute values outside force any negative parts of that graph up. So it's like this. And then the negative flips everything back upside down. So this is your final answer. There you go. That's it. So lots of practice with graphs, finding inverse functions, determining symmetry, proving the symmetry, odd or even. And that's it.